This is Neil Schneider for MTBS-TV at CES 2014. I am at castAR's private suite, and I'm really excited to get a demo of the castAR product. To my immediate right is Jerry Ellsworth, and to my immediate left, who else than Rick Johnson. Welcome to the program.
Thanks. It's great to be here.
Now, I've been very excited about seeing this product. I've seen more than my share of videos online. It's really something to see it in person. So let me start off, before we go into all that, I'd like to hear your stories as well, because it's actually a very, colorful past that brought you to this point. Now, Jerry, let's talk a little bit about yourself first. Prior to working with Valve, you're somewhat of an inventor. Can you talk about some of the stuff you've done?
Ever since I was a kid, I was an inventor. So I would take apart everything that my father bought me for Christmas and try to figure out how it worked. I always wanted to know how everything worked. Eventually, I started taking all these bits and pieces from the toys that I built, and I started trying to invent my own things. And very passionate about electronics and mechanics and optics and chemistry. And I've always tried to apply that to whatever I do. When I was a teenager, I got into building race cars. I actually learned how to weld and to fabricate my own race cars, and I raced them, and I tried to improve them with little computers that I built to control the traction control systems. And beyond that, I opened a chain of computer stores in the 90s, and we were trying to push the edge of what you could do with like computer recovery disks and stuff, so trying to innovate there. And in 2000, I made the jump to do chip design and product development, and started doing designs down in Silicon Valley. And it was all self-taught, just learning along the way. And eventually I had this runaway hit in about 2004. It was this video game joystick, which was a Commodore 64 all-in-one joystick. So I had all these video games that were...
Why was the Commodore 64 so important? Was that an influential computer for you?
Oh, yeah. The C64 is my love. I used the C6. My father bought us a C64. I broke a few of them by taking them apart and jamming forks and knives into the cartridge port. So I had a love.
You're still with us. That's a good thing.
Yeah, well, I've come close a few times, I'm sure. But yeah, the C64 was a dream project. When I got contacted by this company to do a C64 joystick, I'm like, oh, I love it. I know everything about it, and it was a dream project, and the community loved it. It became like this kind of cult classic toy, and it really jump-started my career. And I've done a ton of projects and toys since that, and consumer products too, not just only toys.
Now, I understand you're a big pinball fan.
Yes. So I collect pinball machines. I have about 80 or so now, so I've been collecting them for quite a few years. I love
80 of them.
80 of them. It's pretty bad. My place is fairly big. I have a big garage, but I can't have very many of them set up because they're all set up on end. And actually, Rick is storing a couple of them for me and a few other friends.
Where do you put all the quarters?
Well, actually, I put some out on route at one point in my when I lived in Portland, and their pinball machines are popular, so I was bringing in like hundreds of pounds of quarters when I'd go collect the money out of the machines.
So, you strike me as being an engineer. I hope that's an accurate description. Have you been formally educated in that type of work?
No, I'm all self-taught. I had a lot of mentors along the way. So various folks along the way saw my enthusiasm about electronics or whatever thing I was excited about at that point, and took me under their wing. And it's better than spending 4 years in college. If you can just work with someone that'll just feed you the information directly, you can pick up information really quickly. And so that's how I did it.
If memory serves you, you did some chip design formal training, but you ended up moving on your own, I think, if I'm remembering correctly. Am I remembering correctly?
Incorrect.
Okay. Go ahead.
I did go to a school to use their chip foundry, but then they canceled the chip foundry class, and so never happened.
Do you find that in universities they give the students that they need, or do you think universities are filling all the needs for engineer development?
I think they're filling a lot of the needs. I think really the learning begins when you get out into the real world and you get your teeth knocked in a few times on your first few projects, because there's only so much preparation you can have before you go out, because the world is so big. There's so many design issues. You're going to stumble the first few times.
Okay, excellent. Now, Rick, you get the spotlight now. Okay. You have a very colorful software development background. Maybe you could tell some of the stuff you've done.
Originally, I started out on the Commodore 64 and got a Commodore Amiga and just started to play around with that. A friend of mine in high school, we were both programmers, and met up with a software shop that sold Amiga, which was rare in this country. And the guy knew these two artists that were trying to develop a video game. And so we all got together and worked on our spare time for a year and a half, sent out demo discs physically in the mail back then, and this became Black Crypt for Electronic Arts, and that was the foundation for Raven Software. And from there, that started my professional video game career, and worked on Black Crypt, Necrodome, Cyclones, Hexen 2, Heretic 2, Soldier Fortune 1, Soldier Fortune 2, Star Trek Elite Force, Quake 4, a little bit of Singularity, and then Wolfenstein as well. Left a bit to go to Gearbox, and then went to Valve Software, worked on Alien Swarm, did the graphics technology for Dota 2, was one of the 3 people that started the Linux cabal, and then met up with Jerry, and we started on castAR.
You know, of the titles you listed, I'm going to highlight Star Trek Elite Force, because that's, you know, one of my all-time favorite games. I played it more than once, and usually when you play a game through the storyline, you don't necessarily play it again, but I'm too much of a Star Trek fan, a little embarrassed about it. So what did you do with Star Trek Elite Force?
I played more of a secondary role. I was still the lead programmer on Soldier Fortune 2 at that point, or Soldier Fortune 1. Elite Force was the first Quake 3 engine game that Raven used from id, and so it had a bunch of curved surfaces, and we made a use of that. And
did you mention Left 4 Dead as well?
I did a little bit of editor work for Left 4 Dead to do instancing across the levels, but I wasn't directly involved in that project.
And, you know, we'll talk about castAR's products soon enough, but, you know, thinking back at all the games that you've worked on, would you see them completely differently in VR? Like, do you see them having a reimagined future in virtual reality?
You could imagine, you know, again, like Elite Force, and especially with the curved surfaces, I had such an organic environment that actually placing you there with the away teams and experiencing it more in that environment would completely give you such a different experience than it would be just on a flat screen.
Okay, fantastic. So, wow, it's like the dream team here: the hardware, the software, and of course a winning product as well. So let's talk a little bit about castAR's early beginnings. So you had some time at Valve. What happened there?
So I was the first hardware hire at Valve, and I was tasked with putting together a team to do hardware development. And so we put a team together, and we started exploring all forms of input and output, anything that could make gameplay better. And so one of the things, it was a pure accident one day. I was trying to solve a problem with near eye displays, like the eye strain issues. And I'd built up this optics bench with some projector parts and lenses and beam splitters, and I put one in backwards. And I was trying to look into this thing, and I couldn't see an image. And I'm fiddling around with it and looking at different angles and moving lenses around. And then across the room, there was a piece of this retroreflective material, which is the heart of one of our modes of operation in castAR. And I saw this beautiful image like pop up on the retroreflector, and I'm like, oh, that's interesting. So start thinking about it and looking at it and analyzing. I'm like, well, this actually solves a lot of our issues with eye strain and various issues, and makes the glasses very lightweight and simple. And so I started doing some early tests to see if it was feasible to actually make projection glasses. Started with this big headgear that I built, which we called the head crab, which is a name of a creature that attacks you. And was it Half-Life 2 or Half-Life 1 or both? I don't know. Sorry,
it's okay. No, go ahead. Go ahead.
Not a Valve gamer, except for Left 4 Dead. I like that one. This big rig, big projectors, and we proved that we could project stereoscopic images onto a surface, and they could pop out of the surface, they could extend into the surface, it could make things look like they float above a table or into the table. And like, well, that's very interesting. And so we worked on a tracking scheme with just web cameras. We glued it onto these projectors, and we started doing the very first tests of trying to get graphics to look like it was locked to the table. And we got our very first experiences. Like Rick came and helped, and he made a chess game we called Team Fortress, which is based on some characters out of Team Fortress, which is a Valve game. And started to get the tracking so that it was locked and it looked like these chess pieces were floating there on the table. And we're like, all right, this is really cool. And we started optimizing and reducing and shrinking the projectors and moving towards more accurate tracking that didn't have jitter in it. And so that was the evolution of the very first glasses. And they were all still real big and bulky at the time.
So this almost seems like it was an accidental discovery, which of course you nurtured to health. So what was the internal reaction?
It was kind of interesting. Folks would come down to the hardware group and wear these big, heavy prototypes, and they would play for hours and hours these games that Rick put together. He put together a multiplayer zombie game where you used our wand that we had developed to lead characters through a maze, and the maze would scroll on the table, and each person had their own perspective as they sat around the table. And it was super addicting because you got to be interactive and social with your friends. You got to kind of figure out what they were doing in the maze because you'd see their wands and you'd see their expressions or how they moved their head back and forth. And so in that regard, there was a lot of people coming down and like playing it. On the business side, I don't think that it really fit what they wanted. Valve has like a type of game they do, and it just didn't fit in that way.
So I understand that, things don't work out in life. I mean, that's, I understand that you had an abrupt ending at Valve. Maybe you could quickly tell the story.
I'll never know what actually happened there. Just one day I came in, was going up the elevator, and met one of our mechanical engineers storming out of the building. He said that the mechanical engineer that was working on my project had just got fired. And I stormed upstairs mad and like, how could this be? And then I walked in, and Rick was in our hardware lab, and he was like, I just got fired, and you did too. And so the real reasons behind it, all I can do is theorize.
Well, it doesn't really matter.
Yeah, but the good thing is a lot of times in Valve they would say, we don't care if we ever ship hardware, we just want these things to exist. And so in fact, now looking back, they let us have all the tech free and clear. Well, it took a little work with lawyers and stuff, but now it exists. And so what they wanted was this cool tech to exist, and it exists, and we're doing it.
So do you still keep relations with Valve?
Oh, we have really good friends at Valve, like 99% of the people there. So, and there's some, Rick can probably talk to this more than me, but there's initiatives that Valve's working on that's really going to further virtual reality and augmented reality. Well, virtual reality.
Okay, excellent. So you're going to add something.
Since some things haven't been announced yet, I can't talk about them. So.
I could talk about them on your behalf. I'm joking. Okay. I'm joking. I won't. So there's obviously the hardware side and the software side. So let's talk a little bit about the hardware itself. So you discovered this reflective surface. You've projected on it. You moved on from Valve. You did this very successful Kickstarter. How much did you raise through Kickstarter?
So 1.1, is that the total?
1.05, but yeah, close. Rounded up.
All right.
It was really good. It was really exciting, very stressful to do, but we're very, very pleased, and it's opened up just tremendous doors for us. It's great.
I mean, you must be thrilled. I mean, when you moved on from Valve, I mean, it couldn't have been a happy day. But then you have this Kickstarter, and it's not so much just about the money. There's probably countless of people who put money in. That obviously underscores the value of the product. Yes.
For me, the day we left Valve was kind of rocky, and we had ups and downs throughout the next 7 months or so it took us to develop the glasses. We would go to a show like Maker Faire, which was the first place we showed, and we had lines that were 45 minutes to an hour to get into our booth to see our experience, and people were really excited. So big highs, and then you go back, and now you have this huge pile of work that you've got to do for months and months. and you start to kind of decline. You're like, is this really what I should be doing? And then you go to another show, and everyone loves it, and it was a roller coaster. And then Kickstarter happened, and that really cemented it. It's like it does have broad consumer appeal.
For sure, for sure. So
Rick has opinions. I think he's been
yeah, go ahead.
It was, every emotion possible. You work so many hours that we were both had colds for months on that we probably would ping pong it back and forth. You create something really cool and you're eager to show it off. You go to Maker Faire and you're like, are we going to have lines? Or is anybody going to care? And then like tons of people and tons of press and you always like we're aiming towards Kickstarter, and we do Kickstarter, and we have a successful Kickstarter, and like, okay, now the next phase is growing the business, and I keep waiting for the point where I can say today was easier than yesterday, and maybe someday that'll happen. But I guess if that happens, then the challenges are all done, and challenges are part of the fun.
Very good, very good. So let's talk about the hardware. You've obviously made a lot of enhancements since that first Kickstarter, and it already seems eons past since the Kickstarter. And so where are we at?
Oh, so this is actually an exciting weekend for us. So this is a big milestone for us. We went from the standard def glasses to the HD glasses just 4 days ago. So we got them going, but it's a bigger step than that. We went from a huge control box that had tons of chips and FPGAs and stuff in it to one little circuit board that has 2 chips on it. So it's our first milestone of miniaturizing electronics. And so that's huge. That's going to lead us up into our next step, where we shrink it one more time, and then we deliver our 70 or 80 early developer glasses with this miniaturized electronics. Beyond that, then we're going to take the next step, which is the power reduction through the metallized gate array, and all the various peripherals will be coming online. So it's exciting hitting these first checkpoints and hitting them approximately when we thought we were going to hit them.
But don't forget about the antimatter and the matter and the dilithium crystals. But okay, so why don't we go back to some rudimentaries with how this thing works? So we have pictures, of course, so that we're showing the glasses. Can you explain that there's projectors, there's tracking? How does it all interact?
Okay, so the glasses have 2 projectors, 2 micro projectors that are projecting 720p HD images, one for each eye. They project straight out from the glasses to the retroreflective surface. Property of retroreflector is that all the light that hits the surface comes directly back in the same direction that it came from. So each user is projecting their own image to the surface, and it comes back to them only. So that means that you can have multiple people around the table all getting their own unique perspective and their own images, and they don't see anyone else's images.
I just want to underscore, I tried it. We actually had a second pair of glasses going on at the same time. I was really impressed because there was absolutely no crosstalk that I could see. Obviously it's cooperative. People have completely different viewpoints, different parts of the room. Can you explain this retroreflective material? Is it similar to what they use on bicycle vests at night? Where else do we see this stuff?
It's used all around us, and we may not even realize it. So road signs have it. So when your headlights hit a road sign, it's a very bright image coming back. There's industrial applications with super high-grade versions of it that have little mirror cube corners that are even more efficient for like bouncing lasers around. And the great thing is it's inexpensive. The material that works great with our system is just a few dollars per square meter. It's a fabric that you sew onto bicycle vests, and so you can configure it in different ways.
Are there different grades? Is it all equally good?
There are different grades. So like the stuff I was talking about with the little cube corners is the highest grade, and it's actually not even the best for our application because the light is so directional it goes back into the projector instead of your eyes. So you can get different grades depending on the distances you're working and what you're doing. So fortunate for all of us, the kind of inexpensive grade is perfect for tabletop gaming, or if you're going to do a holodeck or something, you're in a 10 by 10 room.
Excellent. Now, we were seeing a scenario where there were two pairs of glasses. The nature of the fabric, are you aware of any limitations as to how many people can cooperatively view, the image? Computational power, of course, I'm sure there are limits there. But as far as the fabric and the technology, are there any limitations as to how many people can share the experience?
Not inherently. There's probably no inherent limit. If you're looking directly over someone's shoulder, you might see a little bit. There's about a 2-degree fan out of the image coming back. So if you get within, just looking over someone's shoulder, you can kind of see a ghostly image. But that isn't even detriment. When someone else is wearing glasses, their image is so much brighter coming back, you don't see anything.
Let me rephrase the question. Could we have a scenario where 10, 20 people, if the room is big enough, sharing that same space?
Oh, absolutely. And that takes us to the tracking system. So each pair of glasses has a tracking camera and dedicated hardware to do tracking in hardware. And so we find your position in the room by tracking infrared LED constellations, and we can have several hundred of these constellations hidden in the room. They don't interfere with the surface because they're just so small. And the glasses can figure out where they are in the world, and the computer can generate the correct image. Rick can probably explain how the rendering works. But the hardware is independent for each of the glasses, so there's no limitation of how many people can be in the room because the glasses are doing the computation of figuring out where you are in the room.
Yes, Rick, don't worry. I'm not going to let you off very easy. I've got a lot saved up for you.
Don't.
I wouldn't fall asleep if I were you.
Rick gets mad at me when I start trying to explain the software, and I felt dangerously close to trying to explain how.
No. But I am intrigued. I understand this is an optical system for the tracking, but I'm a little out of my depth. Can you elaborate a little bit more as to how it works exactly?
Okay, so we have infrared LEDs. You can't see the light coming out of them, but the camera can. In the LED constellations, they can be different shapes of LED dots, but there's an ID point which is modulating out its ID. So the system you saw had one marker out there, constellation, and that's ID 0. If you want to have a bigger work volume than, say, a table, you add a couple more markers in your environment, and that's the next one is ID 1, ID 2, ID 3, and then you do a calibration process, or if it's in some rigid formation, you don't have to do the calibration process, but then that gives you more work volume, and
So these are markers that you place on the table. Is that how you'd move pieces around in a virtual reality thing, or is that completely different?
So we have some other peripherals that go along with our system. That's just for head tracking. To go along with the head tracking, we have a wand, which uses similar technology, uses the same camera that tracks the same LEDs in the environment. But you can use that as a handheld input device, and you can reach out and touch pixels that are being rendered out in the environment. And so our tracking system is sub-millimeter accurate. So by adding that to props like our wand, you can do the same kind of precision interacting with the 3D space. So that's a very compelling way to interact. And
no, it's okay. I was just going to ask, so two questions. Latency. Is latency a concern with this technology? And also, what's the accuracy?
So we're sub-millimeter accurate. It depends on a lot of factors, how far away you are from LEDs and stuff like that. But the accuracy is extremely high on our tracking in most use cases within a volume. And latency is extremely low because we're doing all the tracking in hardware. So we've been able to cut typically many frames of latency out of a system by doing it in hardware. And also, the advantage of doing hardware tracking is that the computer doesn't have to do that work. All we do is we send a handful of bytes down to the computer from the tracking hardware, and then the computer just takes that, and I'm going to tread into rendering zone, but it renders the correct image and does some magic on Rick's side and generates the image. So we're very, very proud of our tracking system. It's very robust, too, and getting better each day as we do iterations on it.
Okay, very good. And so a couple, just quickly, field of view.
So the projectors or on the...
Well, the outcome, like as a user, what field of view can I expect from this?
So in projected mode, I mean, there's so many pieces, we haven't even covered them all yet, but for the projected mode, there's 65 degrees field of view, horizontal and vertical roughly is what we're shooting for. And then for the tracking camera, we're currently at about 110 degree field of view on tracking, so you have to have LEDs within this 110 degree field of view to keep tracking alive. We also are adding gyros to the next generation of boards, which will keep everything going if you cover up the camera in some way.
Okay.
And then we also have our VR clip-ons that go over the top of the glasses, which is freeform optics, and still in development. We've seen 80 degrees so far in one of our prototypes, and we believe we can get clear out to 90 degrees with very, very low distortion on the VR clip-ons. And the way it works is they clip over the top of the projectors and they bounce the light a few times, and then allow you to do a surface-free augmented reality type experience. And then we plan on having a shutter that you can flip down over the semi-transparent lenses. You can go into full immersive VR mode. And same tracking, everything applies.
So lots of surprises in store.
Yeah. We just went through one of our milestones on the VR clip-ons. We sourced some of the parts that we needed for it, so that's exciting. All these things, like not terribly exciting people outward looking in, but for us sourcing parts for these, it's like terribly exciting. We hit one of those milestones. We got the part that we need, so yay.
Okay, so let's talk about the software side. You've been waiting patiently.
It just works. You don't have to worry about it.
So, when I tried these glasses on, it's like you look around and the imagery, of course, changes where you look. Mm-hmm. It's not that you have this small box. There's actually a world beyond what you're seeing. Can you describe some of the software challenges that you've come across with developing for castAR?
In many regards, the retro material surface almost eliminates the challenges. That the surface bounces the light back to you without any distortion, without any refraction or anything going on. And so whether or not you render the scene from looking straight ahead or off to the side, the computer is rendering on how you should see it. But the surface, if it's there, here, if it's weird angles up there, because it bounces the light straight back at you, it's almost a seamless environment.
I would underscore that as well. Like, the projection surface I was looking at is like almost a 90-degree angle, but when I'm looking at it, it looks like a flat image. And I'm not saying flat 3D wise. Flat is in uniform, properly shaped, no distortions. And had it been a traditional projector on a white screen, I don't think it would be doing that. Am I correct?
Correct. And you could, we could put a piece up off to the side, and it will just look as if it's seamless without the holes that you see around the physical world. If you had a person wearing a shirt and you projected on it, they would look like they're part of the world invisibly to you.
Okay, excellent. So, as far as the software is concerned, I mean, Jerry was talking about a tabletop chess game. What kind of adventures have you been going through with software development?
It's something that we learned early on that we don't know anything about AR, and you think about how do you show something that's effective to the consumer? How do you interact with it? What type of multi-user experiences? Like, if we share the same physical space, am I moving around on the couch now because it's based on our head tracking and what we're doing in the world? And so we just had to run a lot of experiments to just kind of learn how you do things. How do you put information out, HUDs and things like that? What games are fun? What new input means can you do? We did a simple discovery of, if I made a character crouch because you're physically crouching, because I know everything about your head, what does that do for gameplay? And then it turned into a generic concept of an input device. And it's like your head became a joystick, and it turned into a flight simulator. You could look up, down, left, and right, and that controlled your experience flying through a world.
You see, what really excites me about your technology and other technologies coming to market is, I don't know if you'd agree with me or if you disagree with me, because of course you're a very tenured game developer, but the concept of game development, I don't know if it's radically changed all that much dating back to Doom. I mean, the first-person shooter, I don't think it's really dramatically changed. The graphics have of course improved, exponentially, the audio, the voice, everything. But the design, the way games are put together, I'm not sure if it's really radically changed. They've had this wonderful formula that just works. But in this case, would you agree that game developers and content makers need to rethink their whole process?
I would say the biggest change over the last 20 years has been story. That you think about Doom, it's demons coming into this environment, and that was the end of the storyline. There might have been a screen of text. And games coming out nowadays, have full cinematic sequences, and you get more invested in the storyline than you do a movie. And so, there's been mechanics and things like that. For AR in particular, this is now bridging both a resurgence of cooperative and competitive people simultaneously sharing the environment, but also your interactions with the physical world to the virtual world. And I think it's just going to take the concept of gaming and expanding it. It's not going to replace the other forms. It's just going to expand it into new areas that we've never imagined.
Well, you must be very excited about this as a software maker, because I mean, it's not just about releasing wonderful hardware, but I really see this as disruptive technology. And I mean that in the sense that I really think it's going to redefine the way games and content is put together. It's going to, like I would say, like if you have a multi-billion-dollar AAA company, they're on equal footing now with the independent game developers, because they don't know any more, they don't know any less. Just to put this in perspective, how much will this cost? Like when you're talking about commercially released products, what are you aiming for as far as pricing?
Well, our Kickstarter, our starter kit was $189. It's kind of baseline to get you going, and we don't know how to project out when we go into full volume production 2015 and beyond, but that's a very reasonable price point, so a very consumer-friendly price point.
And I would ask, on the software side, you've been doing game jams, yes?
Yeah, we've hosted 2 different game jams right now.
What are you finding? What are people coming up with as far as content?
They're taking simple ideas and just trying them out. And the last game jam was this kind of fish tank fishing game, and you wouldn't think of a fish tank being that exciting, but now you make it as a 3D environment that you can walk around, and you could use the wand to it turned into more of a slapping the fish game. But ideas don't always progress into how you expect them. But
and fish whipping is what the way I would describe it. Was funny. The physics was a little wrong on the fishing line, and that was actually one of the surprises. Like as we're playing with games with this, we're always surprised by physics type things that become fun. And on this, it was just slapping the wand down and just whipping the fish and sending it flying.
Do you think a lot of careers are going to be built based on this technology and other products? And what I mean by that is, if I was a student and I just came out of a game development program, I'm up against every other student applying for the same jobs. But do you think that there could be a whole new independent game development market built from this? And I'll let each of you answer that one. Well, Rick, why don't you start?
I think it's a new way that, if you extend this beyond games, of how industry and professional markets are going to use AR, that it becomes a collaborative environment. That games are kind of the first foray into this thing, and so as people become familiar with it, their skill sets become expanded, and it's just a way to make themselves more employable.
Mm-hmm. And Jerry?
I absolutely agree. Looking at CES today, over the last couple of days, wearable technology is really the next trend. You can see it all over the place. Wearable sensors. There's lots of display companies springing up. It's definitely going to be a big growth area.
Excellent. One more question for you. Video perception. We were thrilled that you added support for it with castAR. I'm curious to know what your experience was. And it's okay if it wasn't great. I mean, it's open source. It's not. No, everybody knows it's not perfect. It's put together by volunteers. But I'd be interested to know what you thought, what experiences you had with it, actually.
Well, the first game I tried was Skyrim, and going from your flat monitor into the Skyrim world, it was an awesome moment when I first got the entire system hooked up to it. So.
Awesome. Did you try something as well?
I tried Skyrim also, and I'm a big Skyrim fan. When we were doing some testing around Valve on game controllers, I played hours and hours of Skyrim, and to see it in this new way where I could just peer around, and it was...
So it worked out.
It was pretty darn cool.
Okay,
Yeah.
fantastic. Yeah, I'll tell you a quick Skyrim story. It's not VR related, unfortunately, but at the university, when I work at University of Ontario Institute of Technology anyway, when Skyrim came out, the professors were having a problem where students were bringing their schoolwork in late and missing appointments because they were busy playing Skyrim. So anyway, I want to thank you both for joining us on MTBS TV. This is fantastic. I'm really excited by this. I think you're going to go very far with it. And it's just, I mean, there's other brands with divisions in the market, and I really think this is going to stand on its own as its own specialty. And I really congratulations to you both.
Thank you.
Thank you very much.
So this is Neil Schneider for MTBS TV at CES 2014. We will, of course, be back with more. Thank you for watching.